Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. On today's episode, we're going to discuss linear approximations and differentials. Sometimes we'd like to know the value of a function at a point where it's difficult or even impossible to compute exactly. However, it might be easy to compute the value of the function at a nearby point, and we can use this information and our understanding of calculus to approximate the value at the point where we desire the answer. So consider, for example, if we want to know the square root of 1.04. We know the square root of 1 is equal to 1, and let us see how we can use calculus to approximate the value of 1.04. So in general, suppose we know the value of f of x when x is equal to x0. We can approximate the value of the function near x equal x0 by considering the tangent line to y equal f of x through x0, f of x0. How do we do that? Well, we have y minus the y value, y minus f of x0, is equal to the slope, f prime of x0, times x minus the x value, x minus x0. We bring the f of x0 to the other side, and we have the equation of the tangent line, y is equal to f of x0 plus f prime of x0 times x minus x0. So let's go back to our example. To approximate the value of square root of 1.04, we consider the function y is equal to square root of x. We know that y of 1 is equal to the square root of 1, which is 1. And to find the equation of the tangent line, which we'll call L of x, at 1, 1, we need to find the slope of the curve of the square root of x at 1, 1. So we take the derivative of y equals square root of x. That gives us 1/2 x to the minus 1/2. Since we're interested in the slope when x is equal to 1, we use y prime of 1 is 1/2 of 1, 1/2 times 1 to the negative 1/2, which equals 1/2. So we get that the equation of the tangent line is L of x minus the y value, which is 1, is equal to the slope, which is 1/2, times x minus the x value, which is 1. Bring the minus 1 to the other side, we get L of x, the tangent line, through 1, 1, to the curve y equals square root of x is equal to 1/2 x plus 1, 1/2 parentheses x plus 1. Okay, we can take a look at the curve y equals square root of x and the line that we just found, the tangent line through 1, 1, and we see that the line is a very good approximation to the curve near x equal 1. So now what we do is we plug in 1.04 into the line, so we find the y value of the line at x equal 1.04, and we can use that to approximate the value of the square root of 1.04. So we plug in, we get 1/2 1.04 plus 1, which is equal 1.02, and we note that the true value y of 1.04, the square root of 1.04, is 1.0198 ... So we see that our approximation, which is very easy to compute, is very accurate. Some things to note about linear approximations are that they are usually good near the point where you find that tangent line. If the tangent line goes through the curve at a given point, then clearly the tangent line is exactly the value of the curve at that point, and that tangent line should be good close to that point. Okay, the true change in a function's value as we go from x0 to x1 is often denoted delta y, while the approximate change will be denoted dy, and that's called a differential. And the approximate relative change in y as x changes by dx is denoted by dy over y. That's how much does y change divided by the value of y when you change x by a little bit. Let's take a moment for math culture. There was a mathematician, an engineer, and a physicist who were out hunting together, and they saw a deer in the woods. The physicist calculates the velocity of the deer and the effect of gravity on the bullet, aims his rifle, and fires. But he misses. The bullet passes 3 feet behind the deer. The deer runs a few yards but comes to a stop, still within sight of the trio. It's a shame you missed, comments the engineer. But of course, with an ordinary gun, one would expect that. He then levels his special deer hunting gun, which he rigged together from an ordinary rifle, a sextant, a compass, a barometer, and a bunch of flashing lights, which don't do anything but impress onlookers. And he fires, but his bullet passes 3 feet in front of the deer, who by this time wises up and runs away. Well, says the physicist, your contraption didn't get it either. What do you mean, says the mathematician. who was also a statistician. Between the two of you, it was a perfect shot. Thank you for joining us today. Have a great day, and may the power of math be with you.